so we've already evaluated functions, so let's take a look at what a composition of functions is. Composition means to put things together. So here's one composition of functions, f of g of 3 and g of, not of, I don't want to write the word of, this symbol, this little circle means of, f of 3. Alright, so these are two different composition of functions. Now what this means is, whoops, for whatever reason the pen doesn't want to stop writing. Okay. Can't see. Okay. So this is what this means. This means f of g of 3. Alright, so it's written like this, but it really means to work from the we're actually going to be working from the inside out. So we can, if we saw something like a of b of c of d of x, that would mean a of b of c of d of x. Okay, so we apply the outermost ones first and then work our way inwards. Alright, so in this case, what's g of 3? Well, when we'll get 2 times 3 minus 5, which is 6 minus 5, which is 1. So this is equal to f of 1. Now we can calculate the value of f. So that's negative 2 times 1 plus 3. So that's equal to 1. So f of g of 3 is equal to 1. Let's take a look at g of f of 3. So that would mean the value of g when we know the value of f of 3. Alright, so f of 3 is negative 2 times 3 plus 3, which is negative 6 plus 3, or negative 3. So that's g of negative 3. So let's determine the value of g of negative 3. So that's negative 6 plus negative 6 minus 5, which is negative 11. Now, the order of composition does matter. As you can see, they gave us different values, so they mean different things. If they gave us the same value, that would mean that both of these functions were the same. It is possible that they give you the same values otherwise, though. Alright, so there is something else interesting we can do here. So here, I'm actually going to make all of this function down here purple, the whole thing. Okay. So let's see what the value of f of, what the function f of g of x is equal to. Okay, because this applies using two functions. We can actually turn this into one function. So what is the value of f of g of x? Well, that's f of 2x minus 5, which is the same thing as if we plugged in 2x minus 5 into f. So that's negative 4x plus 10 plus 3, or negative 4x plus 13. That comes from here. So if we were asked to find f of g of 3, we could just simply plug it into this function here. So it's negative 4 times 3 plus 13, which is equal to it's negative 12 plus 13, which is 1. Same value. Okay. So let's take a look at the purple function down below. Erase all that. Okay, so what is g of f of x? Well, that's equal to g of f of x So that's g of the value of f of x, which is equal to negative 2x plus 3. Now to calculate what that is. So we're going to substitute that into here. So 2 times negative 2x is negative 4x. And 2 times 3 is 6. 6 minus 5 is 1. So that also means g of f of x, g of f of 3 should be equal to negative 4 times 3 plus 1. So that's negative 12 plus 1, which is negative 11, which it is. Alright, so let's take a look at the graphs in this case. Alright, the graphs of these functions. Alright, so first the blue line will be this one. That will be negative 5 as its y-intercept, so it's 3, 4, 5. Goes up 2 over 1. Let's extend that. Okay, so that's the blue line. Now the green line. That would be f. So the blue line is g. This green line I'm going to put down now is f. Okay, the red line was 4x, was it negative 4x plus 13, I believe? Let me just check again. I have to refresh. That was f of g of x was equal to, so that means plug g of x in here. So yes, negative 4x plus 13. So we had a y-intercept that's above the graph in this particular case. So let me just try and figure out where that would go. So if we were at 13, we'd go down 4 over 1 to 9, so 9, 1. 9, 1, and we go down 4 over 1. So that would be this one. So that would be that composition. So you'll notice at 3 they have the same value for and let's take a look at g of f of x, which is negative 4x. What was it? That means we plugged f of x into g. So that's positive 6 minus 1, positive 6 minus 5, which is 1. So that was here. Color purple. Okay. Alright, so you see there's an intersection point between each of these, and that's where the secondary function came in. They give you the same value at 3, and these gave us the same value for negative 3. Oh, forgot to extend the line. Alright, so you'll notice that f of g of x and g of f of x are not the same function. They're not the same as f of x or g of x, but they are just, it's as if you took one function and applied the same thing. So let's take another look at this. So let's say we had, we want to know what f of g of x was. So that would be apply g to determine a value for y, and then apply f. So let's say we wanted to find out what f of, well, this one's obviously purple, so I'll just stick with that. G of f of 3. That means we can either just look at where the value of 3 is on the purple line, or we can look at the value of 3 on the green line, and based on that value, look at the value on the blue line. So f of 3 is here at -2. Is that right? Alright. Did I plot that line wrong? It's supposed to be down 2 over 1, down 2 over 1. I'll make sure this line is plotted perfectly for this. Okay, so if we were looking for this, we would start at 3 here on the green line, and that tells us we get -3. So now we use -3 on the blue line, which is down here, which is where that -11 came from before. Okay, or we could have just went to 3 on this line, which is down here at -11.